or default taggers. So before starting the regular expression code, we must know how to read and write a regular expression. So these are the basic symbols. The first cap symbol is basically the start of the word and the dollar is the end of the word. In between the word we have pipe, that is for or, a dot symbol for any single character, star for zero or more repetition. For example, the first rule written here for determiners is if the start of the word starts with either capital T, the small t, the A or N and ends here is a determiner. Basically, we are just converting the rules already mentioned in the if else state code, but the code size reduces and we can add more rules easily. For example, the new rule added here is for cardinal numbers. That means this question mark is optional. Question mark represents optional. That means we are considering positive signs or positive number along with negative number. If this negative is considered along with any number, that is -5 is also a cardinal number, our code can detect. And if it is only 5, our code can also detect. At the end here, we can see a plus symbol. So it is for one or more repetition, that is one or more digits can be added and it will be detected as cardinal number. And if nothing on the above rules is satisfied, we will be default giving it as noun as a default. So this R in the front is raw string we are representing in Python. Moving to the collab book. Because we are dealing with NLTK, so first is to install NLTK, then import, tokenize. We are importing word tokenize and downloading punct. Somewhere punct tab is also needed, so I just downloaded it as well. For regex expression, we are importing regex tagger. The patterns on the slide is same written here. So we are giving the pattern by which a tag can be given to a particular word. In this, we are creating an object and giving these patterns to this. Now this rule tagger is applied to the sentence, the tokenized sentence. This will tokenize the sentence into different tokens, and on this the rule tagger will be applied here. Yes, drive link will be given and it will be uploaded on Canvas only. You can just refer there. And by this we'll get the tagged statements. Okay, back to the slides. So there is a limitation with post tagger or rule-based post taggers. First is it is high requirement of manual effort. We have to write each rule, and if we miss, our code will not detect that particular tag. Along with scalability is difficult, and that too if the domain is changing, ambiguity will be a struggle, and generalization is also bad. So we just move to next upgraded taggers like statistical tagger or machine learning based taggers or neural taggers. So here we are moving towards statistical taggers. A statistical tagger, there is one function available in one submodule available in NLTK, that is pos underscore tag. So from NLTK import pos underscore tag. This will like for tokenization, we have imported word tokenize and we have downloaded punct. Similarly, for post tagging using NLTK, we are importing post tag. And for this, the downloading should be average perceptron tagger. This is this particular pre-trained model is to be downloaded, and underscore English is specifically ENG is specifically for English models. If you're not downloading this, the error you will get is lookup error. So next is unigram post tagger. Unigram already discussed in the previous session. We are dealing with a single word at a time. and no context is considered in unigrams. Go to the collab notebook. The basic post tagger using NLTK post tag submodule is we are downloading this particular pre-trained model. After that, importing post tag, giving the input, tokenizing a sentence, performing post tagging using the post tag already imported, and then printing the result. So these are the results of the post tagging. Next is unigram based post taggers. So in this, we are dealing with two corpus. First is Brown. Brown corpus is English text corpus available already in NLTK, along with the second text set. This is the text set, universal text set, which already has 17 tags discussed in the previous session as. The only difference is Pentry Bank post tagging the text sets, and the universal text set is the naming conventions. Universal means it simply write noun, Noun, instead of double N for noun. So it is easy to understand. It only consists of 17 tags. So we have downloaded it. Next is we are importing the data set we have downloaded, importing the unigram tagger. Next, we are tagging the unigram tagger with universal tag set. Which data set we are using is the Brown corpus, already downloaded. For the first 4,000 sentences, we are using for training, and the next 1,000 sentences are to test the model. In this, we are creating an object where a train data, this train data, the split 4,000 statements are applied a unigram tagger. Now, the next sentence we are giving for a testing is this particular sentence, and we are splitting it into tokens, applying the tag that is from unigram tagger, and calculating the accuracy. Accuracy is almost about 84.47%. Now, in this, a point to be noted is the swim dot is given a tag as none because unigram tagger is dealing with a single word at a time, do not know about context, and also it no particular rule is there for that to tag any post tag. So for this to be resolved, we are using backoff method. Backoff is if unigram tagger is given any of the word as none in the post tagging, this backoff tagger will be going to the default tagger, which will whatever the default we will give in this default tagger will be assigned to it. That means if I applied back off to this particular unigram tagger, this should be given as noun. So unigram post tagger using back off or with back off. We have imported default tagger, unigram tagger. We need to tokenize it. So word tokenize. The default tagger we are giving is noun. And same as we have applied the unigram tagger in the previous cell we are doing here, and the accuracy is improved here. That is 91.11%. That means the swim is given as noun. Here also the can is given as again verb. Also because we are dealing with Pentry Bank here, so this full stop is separately post tagged with as already discussed 12 punctuation and symbol post tagging is there in Pentry Bank. Similar to the unigram, we have bigram post tagging. In bigram, we deals with two words. The first, that is a specific current word, and the tag of previous word is used to tag the current word. So in unigram, we knows there is the context is ignored, whereas in the bigram, context is considered. For example, if I say I can swim and I bought a can, the first I is basically the first can is basically a verb, whereas the second is a noun. So bigram consider this context, and if I apply back off to the bigram in this, uh, if bigram fails, the back off will give to the unigram, and if unigram also fails, it will give to the default tagger and it will assign noun if no other tag is given to a particular word of a statement. So let us just look at the implementation of bigram post tagger. We are using brown corpus, importing bigram, unigram, and default tagger because we are dealing with the backoff also along with unigram and bigram. So similarly, we are splitting the training and testing data. First 4,000 is for training and remaining 1,000 for test data. Default tagger is given the tag as noun. Unigram tagger, we are giving back off to the default tagger, and bigram tagger we are giving back off to the unigram tagger. This is the diagram for easy understanding. If bigram fails, we'll give to unigram. If unigram also fails, we'll go to the default tagger. So similarly, this chain is been created in these 3 steps. Later on, the bigram tagger accuracy is being evaluated. So it is improved from the unigram with back off also and only unigram also. So these are the post taggers we have discussed. Next part of this session will be named entity recognition. In this, for a given text, we are recognizing the entities. The importance of these NERs is basically, if you think of any of the NLP application, you will somewhere need these NERs to be implemented. For example, resume information extractor. For a company to screen a resume, all they need is the name of the candidate, the skill set he or she is containing, and along with the emails and phone numbers. So these are already easily extracted using NER. Secondly, medical prescriptions. If we see from a patient's point of view, all a patient need is the medicines prescribed by a doctor can be extracted from NER. Another from if an intern, a doctor, if an intern under a doctor wants to read those prescription, all he needs to know is the symptom of the disease, age of the patient, and along with whatever the doctor have prescribed. Also, this can be extracted from NER. Any particular news article, for example, a sports related news article for a cricket match, all we need to know is where the match was, who won the match, by how much wickets, how much, and etc. So again, these can be extracted from NER easily. Chatbots and search engines also work using NER, also uses NER. So the categories of named entities, for the basic, we have person, location, and organization, and the extended categories can be date, time, money, person, product, and event. Now, implementing NER is a little bit challenging because of the ambiguity. For example, if a statement is consisting of a word apple, how do we know it is a company or a fruit? Similarly, a variations in writing, we may write USA, US, or United States. So also how our model will be understanding the variations. Another thing is if we have nested entities, for example, University of Rajasthan, Jaipur, we have multiple entities. It is also a name of an organization along with a geopolitical entity. So it is nested entity. Here, all we need is context. For implementing NER, we need one more step to be added here. We are giving input, we are tokenizing it, We are applying a post tagger to it and giving named entity recognition, and as output we'll get extracted entities. Now here, what is the need of post tagging? If we can just after tokenization can extract the entities, but how post tagger will be helping the NER to perform better is post tagging will be giving syntactic rules. Once we apply post tagging, usually the entities will be noun only. So once post tagging will be applied, it is easier for NER to filter out the nouns and from the given input. For example, a sentence is Anuj visited India. The post tagging of this sentence will be Anuj is proper noun, a singular proper noun, visited is verb, and India is again a proper noun. So NER can easily filter out the nouns and no need to deal with the verbs and or any other post tag given to this statement, given in the statement. Again, NER can be implemented is first, very basic is a rule-based NER. The steps to be followed is you should define the entities you are dealing uh, to be recognized in the particular code. Second is pre-process the text, that is sentence splitting, tokenization, post tagging. Create a list of predefined entities. Example, you are searching for name or you're extracting names. So you should list them. Why we are listing them? Because this is rule based. No other supplementary thing we are using here. So we have to list everything. We have to write everything in the code. Similarly, the list of names should be prepared, list of cities and organizations should be prepared before the actual input is being processed. We may use regular expressions also for date, emails. It is easy to use and also reduces the length of our code to an extent. After that, first of all, the regular expressions will be applied and then the if-else rules will be applied to extract the entities. So let us just see the collab notebook. When we are using a regular expression, all we need to import is import RE. This will allow us to write a regular expression in our code. Next is predefined list of people we want to search or we want to extract from the input. Predefined cities or the location you want to extract. Predefined list of organization. As this is rule based, we have to write it here in the form of list. Next is we are preparing a function rule based NER having an empty list initialized. The input. Here is the input. Now, first of all, this input is being splitted into tokens. Then after the splitting, we will check if the word, the token is present in the list of person, location, or organization. If it is present, the another list, that is the empty list we have initialized, will be filled with that or will append the new values to that. For date and emails, we are using this regular expression. R is representing a raw string in Python. This B is for boundary of the word, and this again, these are the this is making a box to a word. This D in the curly braces of 4 represents the 4 digits in continuation. That means if a number is 20205, it is also a number, but that is not a date or not an year. We want only 4 in exact in row, that means exactly match with 4 digits. So this will not be considered as date, but if it is 2020, it will be considered as date. So here we are extending the date list and adding the entities in that. Arun Verma and Meera Singh started Next Gen Solutions in Metro City in 2020 and left in 2026. So persons are 2, location is Metro City, organization is Next Gen Solutions, and date. Also we have given 2 dates. So if we have more than one occurrences of a particular thing, that will also be recognized. This is basic rule-based NER. Now again, NLTK also supports us to implement NER. For that, to implement NER in using NLTK, the module which we should be using, will be using is NLTK.NE chunk and the tagged tokens. Again, we should remember the flowchart I have already explained earlier. That is, first of all, we should tokenize, then post tag, and then chunk, the NER chunking will be done. So for tokenize, we will be using punct, download punct to split the words. Secondly, for average, for post tagging, we'll be downloading average perceptron tagger, and for and then we'll moving to the NE chunking, that is named entity chunks. So first import NLTK. All the required things should be downloaded first. That is for tokenization punct, for post tagging, average perceptron tagger. For these words is what a large English corpus, a large English word list, that is a corpus. So in this we are tokenizing first the input, then we are giving a post tagging, and then any chunk. So input is this tokenizing, then post tagging, and then we are giving the post tagged to the any chunk. It will give us a tree. Tree is in the form of brackets like this. So my sentence is Anuj joined MNIT in 2015 in Jaipur. So person is Anuj. Also, we can see a post tag given to it, NNP. NNP is, we are basically dealing with Pentry Bank, so it is NNP. Joined is a verb. Organization is MNIT. Again, NNP. In 2015, in and Jaipur is geopolitical entity, so it is separated. So this is basic NER using NLTK function or the sub module, that is NE chunk. Now, this default any chunk can recognize organization, people, geopolitical entities. Now, there is a difference between geopolitical entities and location. Any city, any country or state is taken under GPE, whereas mountains, any name of mountain, river, or any such sort of location related to some nature, it is given to the tag as location. One more is their facility. Any man-made structure, uh, a particular street, a bridge, or a monument is given the tag as, or the entity tagged as facility. If we want to tag this 2015 here, it is only post tagged, not extracted using NER. So the default NE chunking do not extract these cardinal numbers, for which you have, if you want to extract these dates or any cardinal number, you have to use a custom rule, that is using the regular expression, giving the boundary of a word, then four numbers one after the other is represented as a date. So the output for this, and we have detected a year, that is 2015. Now we can also, to make it more visually attractive, we can import tree, and from tree we can use a function that is pretty print. Print the tree. It will look like a tree. So the tree formed here, the NER output we got here is represented in a form of tree. So as these all have no named entity recognized, so there is nothing written above this. Whereas Anuj, MNIT and Jaipur, these are the organization, person and geopolitical entity. So we have given one more node to the tree, that is the entities. Now the output looks little bit difficult to read. If we just want to get only the entities, we can just extract them from the NER tree. That is this. 1 minute. We have this NER tree. It contains the NE chunks. So what we are doing in in this cell is we are initializing one empty list that is for entities. Now in this NER, we are starting a for loop. If this NER have a label to it, that is the particular name along with a label, either person, organization or GP or any other particular named entity, that will be added to this particular entity list. Otherwise, it will be skipped. So if I print Anuj, MNIT and Jaipur will be added to this entities list. I hope this is clear. Now let us move to one of the use case, that is resume entity or information extractor. So in first, we are doing a kind of rule based, or for a particular short resume, we are just taking a sample resume text. We will be using regular expressions. So I have imported RE. I'll be using NLTK submodules. So import NLTK, then tokenize, then post tag, then any chunk. We have given a sample resume text. Then we have created one function, that is extract resume information. All the information we want is name, email, phone number, organization, degree, and skills. If I talk about email, we have it is easy to extract an email using regular expression rather than any other method, because we have this @ sign in that. So how will be reading this? So this is the boundary of a particular email pattern. Next is any word before this, before @ plus any word after this @ is considered as an email. So we'll find all the emails from this from the text given above and should be added to the email list. Second is extract phone. Again, phone number is of 10 digits. So we are making a boundary and 10 consecutive digits are there, that will be considered as a phone number. We will be adding them to a different list. Next is extracting name and organization using NLTK NER. So these two we have done using regular expression, phone number and email. Next is extracting name and organization. For this, we will first tokenize the text, post tagging and NER. Now the tree, if it has label, so if the label is person, see if the entity type or the label is person, it will be added here. And if it is organization, it will append it to the organization list. For degree, it depends company to company what the degree they are basically finding for. So we have using rule based here. So BTech, MTech, MSc, BSc, MBA or PhD is allowed. So we have written it in the separate list and creating a for loop which should go to the input and find out if there any sort of word available that will be extracted from using rule based entity. Next is if you want to extract some sort of skills, that too a company wants a specific set of skills that should be that should be extracted using a rule based. So again, I have written the list of skills a company is expecting, then moving a for loop in it and appending the skills which should be if it is available in the input text. If I execute this, so from the input, we can see the name is this, email we found is this, phone number, organization she have went, then degree and the skills the candidate is having. Now this is again easier, but what we want is if I have some of the data set available on Kaggle, suppose how to use it here, and work upon it. So for that, first method is we can download it from Kaggle, upload the particular data set on the collab file and should use it. Second, you can directly move to this particular tab, that is Data Explorer. One tab will be open. In this, filter for data sets and search for the data set you want, that is for resume. So the first one is this resume. So we will just use this particular data set. So what I have done is uh, to include or to use this particular data set, here is a code snippet. You can either edit to your code or just copy and paste it here. So import Kaggle Hub. The path it is giving us this particular path. So after this, we have got the particular resume data set in our code. Now to know where this particular data set is stored in our notebook. So for that, print the path to know where the data set is. So in the Kaggle input resume data set. Now, 1 minute. The structure of this data set is it have two basic folders. First is resume and data. And this is the summary of the data set. What sort of files is present, what columns are available in this data set. So all we need is this CSV file to be used. So what we are doing, we have to find the path for this particular CSV file. So from this, we have find the path. This path in this resume folder, in this resume folder, we have one CSV file available, that is resume.csv. So I have added to the same uh, path this resume. So we have reached this particular CSV file. Now we will traverse to this CSV file. In this particular cell, we are looking what sort of data set or how the data set actually looks in this CSV. So these are the 5 rows: ID, resume string, the HTML, and the category for which the resume is there. So to know the shape of this, we have total 2,484 entries and the indexes are from 0 to 2483. Secondly, the columns we are asking, the name of the columns are these. These 4 columns are available and the information. Next is I want to know basically resume string, whatever the details is stored in this particular resume string for the index number is this. I said the index is from 0 to 2483. If I access this particular index, so we got one resume details that is for team lead senior analyst. This is the resume of a particular person stored at an index of 976. Another we can see is for, at an index of 258. Now this is a resume for information technology specialist. Another, the last one is for a storekeeper. That this shows there are various categories available in this particular data set for resumes. Now you should apply NER. Now we have got the idea of the data set on a particular data. You can apply NER to extract the required information or required entities. So same whatever we are doing from the start of this session, that is import NLTK, tokenize, then post tag, then any chunk. All should be imported one by one. All the required resources we should download: punct for tokenization, average perceptron tagger for your post tagging, then max entropy, any chunker for any chunk to work, and words is the list of words. Okay. Next is these are the columns from which I am taking this particular column to be used. So I have taken from this data frame resume string and the person or the index number, the resume stored on an index number 5 should be given, and first 500 characters should be printed. So this resume at index 5 is of some HR generalist. The details are given here. Now, similarly, we will be doing tokenization, post tagging, any chunk for NER. And if the label is there, we'll be returning the entities the same way we have done earlier. Now you can, basically this is a particular function. You have to call a function. So write the name and the index number. I have called for index 5. So here we have got some sort of details, but a point to be noted is the keyword is not the actual NER or the entity it has been recognized. Another thing is we cannot just check the accuracy because this particular data set we are using is not a annotated data set. So no accuracy check can be done. To check the accuracy or to clearly extract, or I would say to clearly get the accuracy, we should use some benchmark data set, that is CONLL. So if I use for this name entity recognition, if I use one of the benchmark dataset, that is CONLL 2002. So I'm downloading it. In this particular code, what we are doing, we are using NE chunk also. And for checking the accuracy, we need a ground truth data. So for that, we are using this universal data set, which will having the true tag available. So we'll be checking the accuracy. So for this, the method is exactly same. We will tokenize, then post tagging any chunk, and we will compare. So here we are comparing the output given from the NE chunk and actual output that is there in the CONLL tag. So we got the accuracy as 86.23. So this is how you can extract the named entities. And this is how in this particular cells we have discussed how to use already available data set on the Kaggle in our collab notebooks. So here we ends the first part of this hands-on. Next, we are moving to the errors and debugging. Now, whenever we are implementing any of the code, the errors are the major part which are required to be debugged at a correct time. So there are different types of errors we may face. First is setup and resource errors. Then is data types or input mismatching errors, logic and pre-processing roadblocks errors, environmental errors. Moving to the first one, resource and setup errors. Basically, these errors will apply if you get any of the lookup error in your code while executing. These are because of any of the thing you have not used. For example, if you have imported word tokenize, but you forgot to download punct, that means the resource which word tokenize is using, that is punct, is not available. So you need to know, we have to first download that punct also, and then we have to execute the code. It will work fine. Similarly for lemmatizing also and stop word also. So let me just show you. Okay. So these are the 4 types of error. First, basic error. If you have not installed NLTK and getting the very basic error, you should first install it and then only execute any of the NLP program. If you are not dealing with NLTK, any other library like Spacey or any other should be downloaded first, should be installed first. So I already have this one. First error is missing tokenizer error. The common error we face here is Look, this particular code is giving me the error, that is lookup error, and asking me what should be required for this word tokenize. That is punct. Also, it is giving here you should download punct tab or punct. So if I debug this and now implement, that will implement correctly. So this is the first debugging method. You should download punct if you are using word tokenize in any of the case. Second is wordnet or lematizer missing. This usually comes when you are dealing with lemmatization or stemming. So here again a lookup error, that is the wordnet resource is missing here. That means whatever the sysnet is using is a wordnet. So this wordnet should be available, then only the sysnet should work. If a sysnet is a machine, for this particular machine to work, the fuel is wordnet. So you have to download it. Let me just debug and run it correctly. Now this particular code works fine, and we have downloaded the wordnet which is required for sysnet to work. Third one is stopwords language error. This is when you have not downloaded the stopwords and you are separating or you are removing the stopwords. First possible way, you can just make it rule based. If a particular word like is or or the is available in your text, you can just remove it. That is a basic code. But if you're dealing with so many of cover all the stop words, you should first import them and use. So if I execute this, the error I'm getting is stop words are not available. So what is the list this particular import stop word should use? So we have to download the stop words. Basically, it is a list that should be removed. That should be checked for a word to be removed. So to resolve this, we once I have downloaded this stop words, now I have a list of 198 stop words that that will be removed from your input text. Moving to the second type of error is data type and input mismatch. In this, the first error we are having is post tagging a raw string. For example, as we know, for post tagging, we need this average perceptron tagger. For English, we are dealing, so for specifically for English. Now, as an input, I have this raw text or any of the text, that is hello world. Now, if I'm passing this to a post tag, that means I have not actually tokenized the word. So for NLTK post tag, this particular string is given as an input. So that will not be able to post tag it. The error you will be getting is expected a list of string and got a string. That means you are passing this as whole. And what it should be giving, that is hello, comma world. That means a list should be given rather than a string. To correct that, we have to tokenize, because I have to tokenize this input as into two tokens, that is hello and world. You can use split also, but here I am using tokenize. So this is the raw text. Correct way to do is first to tokenize and then pass the words to the post tag. You will be getting correct tags. Now this is working fine. Next is lowercasing a list. For example, I have tokenized the input, the text I have given. So now the input is this. I have tokenized natural language processing is fascinating. The error, okay, the code you will be running here is tokens.lower. This tokens consisting of all these, and you are lowering a particular list. You are not lowering a word or the particular word of a list, rather a list. So the error here is list object has no attribute of lower. That means you are passing entire list to a lower, which is wrong. So how to debug it? You should first lower the word whatever the words are present in the list rather than lowering a list. So how will be doing it? The words available here, that is tokens available here, are being taken forward. So for word in tokens, we will moving a for loop here and converting each of the word present in the token into a lowercase and printing the lower tokens. So now we'll be getting this. Next error is limmatizing a list. For this, lemmatizing a list basically happens when a developer tokenizes a sentence and then tries to lemmatize the entire list. So again, actually, this is not been commented, so executed correctly. But okay. So in this, I have imported WordNet lemmatizer. Now these lemmatizing, the input is given to this lemmatizers in a form of tokens. The error we are giving is, we're getting is a list. That means we are applying a lemmatizer on a list rather than the elements of the list. So we have to use a for loop for this to move in the list and lemmatize each of the token that is present in the list. So I just comment this and now this will work fine because the tokens present in the list is being lemmatized rather than entire list. The third kind of errors is logic and pre-processing roadblock errors. So for this, the example, import NLTK. From NLTK corpus, we are importing stop words. From NLTK tokenize, we are importing word tokenize. For word tokenize, we need punct. And for stop words, we need stop word as already discussed in the previous cell. We have downloaded everything. Next, what we are doing is we are creating a set of stop words that are present in English. So the text I'm having is the system is under development and it is working well. I have tokenized it. The tokens will be so these are the tokens we got. The system is under development and it is working well. Full stop. So the filtered words. So if what we are doing is the objective of this particular code is to remove the stop words. The original and this list represents the output after the removal. So the system is removed next under development and it is working well. So what is available here is this particular it and this particular the. It should not be included in stop word, but this is giving us the wrong stop word removal. So how to correct it? From in the very start, I have mentioned that for determiners, we are using dot lower and then removing or then post tagging a determiner. So same here also, we are lowering these particular words and then removing from the stop word. So if I just debug it, now these are the proper filtered output after the removal of stop words. So the actual input was this and it is well. The removal of the stopwords correctly, the output should be system development working well. So we have got the perfectly filtered output after the removing of the stopwords. Next is some environmental errors are also there. First is regular expression parser syntax error. In this, we are importing NLTK. We are giving a tagged sentence is an input, that is the as determiner, quick is adjective, brown adjective, fox is noun. So if I write this particular regex for this, what the error we are getting, value error we are getting. Why we are getting this? Because the regular expression written here is not correct. Let us just decode this regular expression. So we are saying a noun, semicolon, a determiner will be there, question mark means an uh, optional. This is adjective into a noun. So first thing missing here is this particular curly braces. The start of this curly braces is missing, and there is no need of this optional symbol, that is question mark here. So if we remove this, the error will be resolved. So let us just resolve the error. So I have corrected it. NP. First resolution of the error is this particular curly braces and and this particular question mark. Now we are getting the correct post tagging after the regular expression. I hope this is clear. Now moving to the another error, that is for n-gram input order. So what I'm doing is importing an LTK. For n-grams, we have to use a particular submodule of NLTK, that is util. And from util, we will be importing n-grams. Suppose my text is crop disease. Here I have a list. I have this particular text. I'm giving it to a list where n-gram is giving us 2. So we are dealing with basically bigrams. So this is an example of character bigram. If we want to split it, it will be working on each character, that is CR, and it will make the pair of 2 characters of a particular word. So crop, the bigrams for the crop disease will be CR as one, ROOP, P and space. Again, space is also considered, and then space and D and so on. So this is not how the n-gram should be executed or implemented. Rather, the thing missing here is we have to tokenize it. Tokenization will result in the output in a list that will have 2 basic entries. First is crop and disease. And if I execute that particular bigram or a unigram or a trigram trigger or a splitting, that should give us a proper code. For example, the debugging of this particular error is, let me execute it. So the debugging will be like, what was missing here is tokenization. So we have just import word tokenize. Then punct already we have downloaded so many times. So if you are doing for the first time, you should download punct also. The text here is Perl, Millet, Blast, and Rust. So here we will tokenize it. And after tokens, we will get the list as this is the list of tokens we got. Look, this is the list of tokens. Perl, separate, Millet, separate, Blast, and Rust. All are separately stored. Now we are applying bigrams to it, or any of the, like here, if you change this, you will get trigram or unigram. So we are dealing with here bigram only. So now I am passing this token list here, applying bigram, which was taken from the util submodule. And then printing this, we will get correctly bigram splitted tasks. Another error you can get is because of the naming convention. Suppose if you have named your file as NLTK only, so that will basically collide with the actual library. So if you will use your import nltk.py suppose in your library, and if your name is also nltk, that will be creating a confusion and will not work fine. So it's better not to name your file with any of the library available to avoid this sort of error. There are certain more errors available. Let us just move to this particular slide and cover them. So we have already discussed setup and resource errors. These are basically when you attempt to use an NLTK function which requires a particular resource like like a data set, and you have not downloaded it on your machine or a collab notebook. So for tokenizer, lemmatizer, and stopword languages, we have got the lookup error. Next is data type and input mismatch. So here we already implemented them and check how to debug them. First one, we are giving raw string as an input for a post tagger, which is not correct. Next is lower casing a list. A list do not have any function named as lower. So you have to lower the elements of the list rather than entire list. Similarly with lemmatizing also, you should not lemmatize the list. Rather, you should lemmatize the elements present in a particular list. We have already seen how to debug that. So next is logic and pre-processing roadblocks. The lemmatizer, improper stopword filtering, and immutable post-tag tuples. Finally, the environmental errors. Here we have already covered this regex, regular expression parser syntax error, and ngram input order, along with the naming script. So these are the references. Is a great idea to refer the official documentation of NLTK for any of the application you want to use. Like for tokenization, they have a separate module entirely on the website. For post tagging NER, they already have a particular documentation. You can just refer and also can use different sub modules which have not been discussed here yet. Let me know if you have any question. I hope you have understood the hands-on we have covered so far. So we have implemented post tagging using role-based and statistical post tagging. In rule-based, we have done if-else and regex. After that, we have completed the statistical post taggers and NER along with errors and how to debug them. Please write the questions if you have any in the chat box.